All right, so now we're going to do the same thing for part B. We have the sides of a square increase at a rate of 3 meters per second. Same setup from up here, but we're going to move down here and say at what rate of change in the area is there going to be when the sides are 20 meters long. So we're just going to change it a tiny bit. But instead of just going back and using our old work, what I'm going to do is show you how to set it up all over again. So let's say, just to go through the steps of doing this, what do we do first? First, you come up with the equation that relates things. So we're going to write it down again. Our equation, we have sides are increasing, and we're talking about area. So area and sides with a square is going to be A equals S squared. After you do that, you write down all of your letters. So we have A is for area. So there's our first variable. So we're going to get an A equals. We have S is for sides. And then, because we're going to take the derivative of this, we're going to get a dA dt equals and a ds dt equals. Okay? So now we're going to figure out what we're given. Again, it says the sides of a square increase at a rate of 3 meters per second. So I know it's sides, so it's going to be S or ds dt. And the way you figure it out is if it's a rate of change versus a variable. So it's increasing at a rate of 3 meters per second. So that increase tells us it's a rate of change. It's ds dt. It's 3 meters per second. The other thing we're given in part B is what rate is the area changing when the sides are 20 meters long. So we're given S is 20 meters. So we must be asked for this area. So how fast it's changing. What is the rate of change? dA dt. We're always solving for a derivative. But we're missing a variable. We might not even need to use it. But to find a missing variable, you plug into the original. So I would go back into my original function, which is A equals S squared. And I would plug in to find A. So if I want to find A, which we may not need it, if you're ever missing a variable though, you plug into the original. So A equals S squared. So 20 meters gets squared. So the area, 2 squared is 4. So 20 squared is going to be 400 meters squared. So we can fill out everything except for the one rate we're solving for. And this dA dt is going to have the units with A, which is meters squared, over the units for time, and this one is seconds. Okay, so you write your equation, you write down your variables and your rates that you get from them, and then you are ready to take the derivative to plug in and solve for whichever rate you are solving for, which for this one is dA dt. So my derivative with respect to time, derivative of 1a is 1 dA dt, which you can write the 1 or not, it doesn't change anything. Derivative of 1a is 1 dA dt equals derivative of s squared is 2s ds dt. This one I'm not going to put the units in on. I'm going to find dA dt by plugging in for each of these letters. So I'm going to have 2 times my s, which is 20 for this one, times my ds dt, which is 3. It's increasing by 3 meters per second. So if 2 times 20 is 40, times 3, it's 120 meters squared per second. Does it make sense that I got such a positive answer? Yes. How we would interpret this is as the sides increase by 3 meters per second, the area increases by 120 meters squared per second. So I'd be concerned if I got a negative answer, but it makes sense as the sides increase by 3 meters per second, the sides are getting bigger, the area is getting bigger as well.